Okay, so here's where I will be able to represent all x values in inequality and interval notation. When we've been solving things with absolute value, we've been representing our answers or our solutions in our set notation. And there is a set notation when we're talking about inequalities, but there's also inequality and interval notation. This is essentially a review from 7th and 8th grade math, but I know that we all had different teachers, and so there are going to be some things that I'm going to highlight that are going to be essential to our success going into absolute value inequalities. All right, so let's talk about the numbers between 2 and 5. If I were to make this statement, write all the numbers between 2 and 5, we know that the numbers in between 2 and 5 are 3 and 4. So all the things that are in between 2 and 5, but notice I did not include 2 and 5. And so if I was showing this on a number line, and I'm going to use a different thicker pen so you can see it. If I were to be showing this on a number line, I would have an open circle with 2 and 5 because I didn't say write all the numbers between 2 and 5 and include the endpoints. I just said write all the numbers between 2 and 5. And over here to the right, you can see those three notations that I'm talking about. When I'm not including things, I'm doing an open circle. You'll notice that our inequality symbols are simple inequality symbols, and we'll talk about those in a second. Notice that X is in the middle because we said the numbers in between, and we actually call this an AND statement. So the numbers in between 2 and 5, so that is how we would write this in inequality notation. We take inequality notation and make it fancy, is how I teach it. We make it fancy, we put makeup on it, we put on its nice boots, and it goes out. And notice that it's the same thing in the house or in the set. It's the same, except for set notation, we're also going to include, we call them braces, right? The braces, and then this X right here is just, and we read this like, it's like you're writing math. We read this as the set of X such that, and then this is the inequality. So notice that if you have your inequality notation, you're going to be able to do set notation pretty easily. The one that's slightly different is interval notation, and interval notation can have parentheses, or it can have something called brackets, depending on if the numbers are included or not, and I'm going to talk about that in a second. But notice here I said the numbers between 2 and 5. I did not include 2 and 5, so I used parentheses, and we are talking about the numbers in between them, so we just use a comma. So this is just like a basic overview of the three notations, and I'm going to explain them a lot more in detail here in a second. Really important symbols for you. Notice that we have less than, and then less than or equal to, and they're very similar except one has a line underneath it. What we're saying is here we're not including, and here we are including. Same thing with greater than and greater than or equal to. So whenever we have an open circle, we are not including, notice regular symbol. When we have a closed circle, we are including, and so we have the line underneath, and it's a closed circle. We're going to talk about domain and range later, so we'll get to that. We'll actually have a domain and range lesson in the future. I want to get to the notes because that's really the most important part, and I'm going to start here at the top. A closed point, we're going to show that as a filled in or solid circle. Closed circle, right? What this means is we're going to include the number. We're going to include whatever that endpoint is, and that's why we use a closed circle. For an open circle or open point, it's an open circle, right? And it does not include the number. We talked about the three notations: inequality, set, and interval. For inequality notation, anytime we're including the endpoints and we have this closed point, we are going to use the symbols less than or equal to or greater than or equal to, and notice that they have a line underneath. However, when we do inequality notation and we're not including those endpoints or not including a number, then we're going to have open without the line, and we're going to have one or the other. Set notation is fancy inequality notation, so we're going to just copy that because we're going to have the same symbols since it's the same thing, just one's a little bit more fixed up than the other. And interval notation, like I told you before, whenever we're not including, we're going to have those parentheses like our previous example, but when we are including, we're going to have those brackets. Now, there's something super important about interval notation. We can have infinity in the interval notation, and infinity, somebody in my third period class said it very well yesterday. Infinity is a concept in this sense, not necessarily an exact number, because infinities, negative or positive infinity, is an infinite possibility of numbers. And so we can't use brackets. We're never going to quote unquote include infinity. We're always going to have them with parentheses. So your infinities in your interval notation should never have brackets. They should always have parentheses. So I'm going to do two examples just to kind of get your brains going on what this is talking about. And we're going to look at number lines. So lots of number line notations here. So here I have a number line. And on this number line, I have a -4 on this side and I have a 9 on this side. And notice that they are closed circles on both, which means those numbers are included. So we're including those endpoints. And notice that my shading is in between them. So that means all the numbers in between -4 and 9. For inequality notation here, remember I told you that we're going to use those inequality symbols, and I'm going to show you the quick way to do this every time. It always works when it's multiple, when you have two numbers that are already designated. So here, notice I have -4 and 9. -4 is smaller than 9. I'm going to write the -4 first. Some of you have been getting away with not putting the smaller number first in set notation. You will no longer be able to get away with that. It always has to be the smaller number on the number line. So -4, and we're going to go to 9. And we're going to have, remember that we said all the numbers between. So if we're talking about what are the possible x values and they're in between, x needs to be in between. So when we're doing inequality notation with two numbers, we're going to write the smaller one on the left, the bigger one on the right. And how do you determine which symbols to use? Well, if you have two given numbers, your symbols must point, and we're doing the in between, your symbols must point in the same direction. And they're always going to point towards the smaller number. But now you have to ask yourself a question. Is it closed circle, open circle? Meaning, am I including those endpoints or not? And if we talked about it earlier, we're including both -4 and 9. I need to make sure that my inequalities have the or equal to underneath. And that's what it looks like for inequality notation. Smaller number on the left, bigger number on the right. Always point towards the smaller number with x in the middle, and then line or no line depending on open or closed circle. Set notation, we're going to take that and make it fancy. So we're going to add our braces, the set of x such that we add that bar, and then we're just going to copy exactly what we wrote for inequality notation and close our set. Now the interval notation is the one that's a little bit different. When you're given the two numbers, always write the two numbers in order from smallest to biggest, and then you ask yourself, did I include those endpoints or not? If the answer is yes, they're included, then we're going to look at this closed point, which means we're going to be doing our braces. If they're not included, we're going to do open point. And it's, remember that infinity will never have brackets. The other thing is you can have one endpoint included and one that's not, kind of like the one over here on the right. Notice again, I'm doing the three notations, and I have the same numbers, -4 and 9, but now look that this is an open circle. It's a very obvious open circle. You must write very neat. You cannot be like, oh, miss, it was supposed to be open, it just looks closed. It needs to be very clearly defined as open or very clearly defined as closed, or I will mark it incorrect. That's just how math is. It needs to be clear. The details matter a lot. If you put a parentheses instead of a bracket, it's incorrect. So please make sure that we're working slowly and clearly so that we don't make silly little mistakes, right? Okay, so inequality notation, same numbers, -4, 9, just like before. X is still in between because we're shading in the middle, and I told you we always point towards a smaller number. But notice here the -4 is not included and the positive 9 is. So I'm going to include the or equal to on the one closer to the 9 because the 9 is included. I'm not going to do anything with the side on the 4 because it's not included. Set notation, take that inequality notation and make it fancy, and we're going to write it exactly as we wrote it. And close our braces. For interval notation, I'm going to write -4, 9 because those are the numbers that I'm looking at. I'm going to include the 9. Like we said, it's a closed circle, but I'm not going to include the -4. And notice here we have one parentheses and one bracket, and that's okay. We don't always include both numbers. That means that 9 could be a solution, and we can get very close to -4, but we're not going to get to -4 exactly. So that is just the general idea of what we're reviewing today. Let's go to the exploration and go ahead. I would pause the video here and go ahead and see if you can do this next 3 on your own. Just give yourself a few minutes. Don't spend a whole lot of time on it. All right, so now I'm going to give you the answers so that you can compare your answers to mine. Notice we have -9 as my small number and 1 as my big number, and x is in between. I told you we always point towards the smaller number when it's an in between or an and statement, and all the numbers between -9 and 1. And I'm including the -9, so I'm going to do or equal to here. And notice open circle on the 1. I'm not including it, so I leave that side alone. For set notation, you should have just copied that exactly, and we're going to do -9. And then, oh, I included an extra line. And then I'm going to draw my 1 and close my set. For interval notation, my 2 numbers we agree are -9 and +1. We're including the 9. We are not including the 1. Give yourself a second to make sure you did number 2. Correct it now that we did 1. Okay, for 2, I have 2 numbers again, -5 and 2, and I'm looking at the numbers in between, so x is going to go in between. We're always going to point towards the smaller number, and we have open circles, so none of those are going to have the line underneath. For set notation, I'm going to take it. You guys know that my sets look very bad on this iPad. Like, I don't know what that is even. Let's try it again. Not getting any better, whatever. X such that -5, and then x, and then 2. Now, also, guys, on your assignment for today, I have a description box, which means you're going to write it. And I want you to write it correctly. What I'm saying is, for example, on the first example here, you wouldn't say all the numbers between -9 and 1, even though that's correct. If we're reading it through inequality notation, this is actually all the numbers. Notice we started as our smaller number is -9. All the numbers greater than or equal to -9. But then if we look from the 1, we're going this way, and less than 1. So we're going bigger than -9 and smaller than 1. So we would actually write this as all the numbers that are greater than -9 and less than 1. For number 2, all the numbers that are greater than -5 and less than 2. And I don't think I said or equal to, but remember to include the or equal to with the -9. Go to example 3. Example 3 is slightly different because you don't have 2 defined numbers. I know that here I'm going towards -infinity because I'm going all the negatives, and here I'm going towards positive infinity. Remember, infinity is a concept, not a number. So I don't have two exact numbers, I have 1. But some of you will treat a negative infinity as a number, and you'll put negative infinity and -2, and you'll put x in the middle, and you'll point towards a smaller number just like we've been doing before, and -2 is included. And unfortunately, this is incorrect, because with inequality notation, we cannot include infinity. So how would you do this? How does Miss Medrano recommend you do this? If you need to write the negative infinity for your own health, write it, but take it off in your final answer. So I would just ignore this part and say my answer is x is less than or equal to -2. This would be my final answer because, like I said, inequality notation cannot include infinity. So negative or positive infinity. The other way to look at this is to look at this number line. Do we see that the arrow is pointing this way? So when I see this -2, I know I'm going to have a -2. And x will always go first, even if there's just one number, x goes in the front. And notice I have my arrow pointing this way, like we agreed. Well, that's the symbol that I'm going to use. So your arrow mirrors the symbol. Do you see that it's the same shape? So the arrow's open that way, which means it's pointing towards x. Then this is also going to point towards x, and we're going to do or equal to and put a line underneath it. For set notation, we're going to write it exactly as inequality notation. If I give you inequality notation, there is no reason for your set notation to be incorrect. If you have inequality, you have set. It's a freebie. You just need to make sure you include the braces and the x such that. Now, interval notation can have an infinity, positive or negative. So if I have interval notation here, I'm going from negative infinity all the way to -2. We're going to include the -2. And remember, I told you we are never going to use braces or brackets for infinity. We're going to use parentheses. Infinity is a concept, not a number. So then take a minute to make sure your notes match mine, and let's go to page 2. But before we go to page 2, look at the top of my notes. I have no space up here. Your notes have a little bit more space than mine, so I want you to draw just a small number. Oh, I don't know what happened. Draw a small number line right here. And this is going to help you because I have it on the top of my notes. This is the less side. This is the greater side. This side goes to positive infinity. This one goes to negative infinity. So we know these are the negatives. These are the positive numbers. Right? We agree? Cool. But the biggest part is, remember I told you that the arrows on our number line actually help us figure out which symbols to use. So those are your two. If we're going to shade this way, we're going to use the greater than symbol. But if we're shading this way, we're going to use the less than symbol. And if you forget, it's on the number line. So make sure you write this kind of small at the top. The other thing I want you to include is I have it on my notes because even though I'm a math teacher, sometimes I like to make notes for myself. My first note is that there is no infinity in the inequality notation. But the interval can have infinity. So I put yes infinity here. Okay? The other thing is same as inequality. You're going to hear my child here in the background. Same as inequality. And then for inequality notation, I put smaller number first. I'm going to do these, and I suggest that, I'm going to do them kind of like straight through. I suggest that you pause the video and do as many as you can, and then when you get stuck, unpause the video, compare what you have, and then look at an example. Because you need to make sure that you know how to do these on your own. You will have a DOL over this next class. Okay, so if you're not given a graph, that should be the first thing you draw. With the graph, all you're drawing is a line, the arrows, and the numbers that are important. You don't need to do all this extra stuff that I did on those because those are easy for me to print. We just really care about the 8 in this problem. Do we agree? So you have a number line and an 8. And if you look at your inequality symbol, do we agree that it's open, pointing towards the 8, which means it looks like this side of the number line, which means when I shade, I'm going to be shading this way. And you don't always have highlighters on tests and things like that. So the way that you can show shaded quickly is just do like a squiggle. Now my question to you is, I know it's pointing that way, it's open, so I'm going to go greater than. And some of you saw that symbol and like, oh, that's greater, I need to go to the right. But some of you don't know. Use the arrows as your guide. And then the question is, do I need an open circle or a closed circle? Notice it's not or equal to. So I'm going to do a very clear open circle. I was given inequality, so I should have done this set notation first because you already know what it is. And for interval notation where we can't have infinity, notice I'm going towards the positive infinity. So it's going to be 8 comma infinity. Positive infinity always goes last. Negative infinity always goes first. And I'm not going to include the 8, and I can't include the infinity. So I have 8 comma infinity, and there's parentheses around both. For the second one, I'm going to draw this number line again. The important number here is -2. And notice it's an or equal to, and it's a closed circle, very obviously closed. And if you look at your symbol, it is pointing that way towards the left, which means it matches the arrow on the left side here, which if I forgot, that tells me I need to shade towards that direction. And you should know that this is all the numbers that are less than -2. So how do I read this? X is less than or equal to -2. My set notation should have been done quickly because we're given the inequality, and it's the same, just fancy. And here, notice we're going towards all the negatives. So this is a negative infinity, comma, -2. You will never put the -2 first. Oh, I apologize. The 2 is included. You will never put negative infinity second. Negative infinity always goes first because it's all of the small numbers. The third one is like the ones we were doing on the front page. We have two very clear numbers. I have a -3 and a +8, and it's shaded in between, so X goes in between. And I told you just point them towards a smaller number. Point, point. So it's the less than symbol. We're going to include the -3, but not the 8. So now that I have my inequality, I can copy over my set notation. And for interval notation, we love having two numbers. It makes life easy because we're just going to write the two numbers, smaller than bigger, brackets if it's included, parentheses if it's not. Number 4 is just like the ones at the top, but this time I gave you the number line. Notice there's a -9, and you're like, oh God, there's a -9. It's only one number. Don't forget there's going to be an X. There's always an X. Oh, Miss Medrano, I don't remember what symbol to use. Look at your arrow. Do we see that the arrow looks like the less than symbol? That is the symbol we're going to use here. It's an open circle, so we're going to leave it alone. Set notation. And then notice we're going towards the negative infinity. So this is negative infinity, comma, -9. Remember, you drew this at the top of your paper. Negative infinity is never included. 9 is not included here. And I'm finished. I'm given two numbers in interval notation. Remember, when we're given two numbers in interval notation, it's the numbers in between. So I'm just going to draw a quick number line, and I'm only going to write the numbers that matter to me, which are -5 and 7. You don't need to write all the numbers in between. Notice I have a bracket around the -5, which means closed circle, and parentheses around the 7, which means open circle, and I'm shading all the numbers in between. So how would I write this in inequality notation? Smaller number first, bigger number last, X is in the middle, point towards the smaller number, include the 5 but not the 7. I would write this in set notation just like inequality notation. And I'm finished. The next one is a tricky one. Do you see that no number is defined by an open or closed circle? I'm going from the negative infinity to the positive infinity, and in interval notation, this would be written as negative infinity to infinity because we can have infinity. This is actually when you have the solution all the real numbers. So for inequality notation, we can't have infinity, so we truthfully cannot write this. Even though it's correct, we can't write this. So how would we write it in inequality notation? We would say X is an element. It's like a little mini squiggle E, and then of the real numbers. Let me redo that so you can clearly see what I'm doing. X is an element of all the real numbers. And then for the set notation, it would look like the exact same. X is an element of all the real numbers. Or you can write all the real numbers. That's the tricky one on this page. Okay, let's keep moving so we can get done. Notice I have two numbers with a comma in between, which means I'm going to write -2 and 10. They're both included. They both have brackets, and it's all the numbers in between, which makes our life easy. When we have the two numbers, smaller number first, bigger number here, X in the middle, point towards the smaller number. So now we have our set notation. I hope I haven't lost anyone. Pause it and redo it if you need to. Here on this one, I have the set notation. If I have set notation, I can take off the extra stuff and I'll have inequality. Once I have inequality, I notice I have two numbers. So I'm going to draw my number line. I have two numbers, 2 and 6. There's no line underneath, so they're clear open circles, and I'm shading in between. For interval, this would be 2 and 6 and parentheses. All right, this is X is greater than or equal to 0. Oh, let me just say that. Don't forget when you're just writing your descriptions, for the one, like for example, the one right above the x is greater than or equal to 0, it would be x is greater than 2 and less than 6. Just remember that. Okay, for x is greater than or equal to 0, if you didn't know that that was the greater than symbol, you can just draw the 0. You know it's a closed circle, and we're shading towards the positive numbers, so we know it's greater. So when I write this, I'm going to go 0 is the smallest possible number, and I'm going to infinity, so we know that that has parentheses, and the 0 is included here. And for set notation, we're going to copy what was given to us. All right, here I'm giving interval notation. Always draw a graph. Graphs are nice because they help us. I'm going to draw a -4, and notice I have an included -4 because it's a bracket. And I see a negative infinity, which means I'm going towards the negative numbers. So if I'm writing this, I only have one number, it's 4. I can't put infinity over here, but I have to have an x. And notice that I'm going towards the smaller, towards the less, and -4 is included. So this would be the set such that x is less than or equal to -4. Same thing with the next one, except this one's positive infinity. I'm going to draw my graph. I'm going to put a 1. This is an open circle though, and I'm going towards the positive infinity, so I'm going positive. X is going to go first and then a 1, and we're going open towards the positive. I'm going to have an open towards the number, and it's not included. So this would be the set such that x is greater than 1. Where it starts, I'm going to skip to the very last problem because it's actually very similar. We have a 5, that's my only number. So I know I'm going to have a 5, and I have an x, and I'm going towards the positive, so I'm going to have a greater number, and it's open circle, so not included. That allows me to do my set notation. And for interval, I'm going towards positive infinity, so 5 comma infinity, and neither one of those is included. The big ones are the ones in the middle. Those are super important. Notice it's an or statement. So let's say you didn't remember anything that I taught you, but you remember how to draw a number line. So let's draw our number line. When I draw my number line, I'm going to put -1 and 4 here because those are the numbers that matter to me. I'm actually going to draw them a little bit closer together. Do we agree that there's no line under the -1? So I'm going to have an open circle. And on the +4, there is a line, so I'm going to have a closed circle. We're going to shade in the direction that we're being told by the symbol for each individual number. So notice for the -1, I'm pointing this way, right? I'm pointing towards the negatives. I'm going to go towards the negatives. And then for the 4, I'm open and I'm pointing towards the positives. I'm going to go towards the positives. Do you see that now it's not an and statement? It's not the numbers in between -1 and 4. It's the numbers on the opposite sides of them. This is called an or statement. It's this piece is a solution or this other side is a solution, but there's a gap. So for set notation, we're going to copy what's given to us in inequality. But the difference is with interval notation, how do I do this, Miss Virginia? You're going crazy. Okay, let's treat this as two parts, and then let's put them together. So we're going to start at negative infinity. Do we agree? We're going negative infinity, and then our first stop is at -1, which is not included. And then we're going to pick up where we left off. We're going to skip some stuff. We're going to pick up at the 4, and we're going to go to infinity. But I can't have a solution that's two separate pieces in interval notation. So what am I going to do? I'm going to unite them or create a union by doing a U. So we would call this union. So negative infinity, comma 1, union 4 to infinity. The union takes the place, this U takes the place of this gap. Okay, so let's look at the one underneath it where you're given the graph. Does everyone agree? I have a 1 and I have a 4, and it's a separate thing, so I know I'm going to have an or statement, and I have to have an X on both. So notice for the -1, I'm going to use the less than symbol, and for the 4, I have the greater than symbol, but it's included, so I need to make sure to include the line. Pay attention to open and close circles. So set notation is pretty simple. We're just going to copy it. for interval notation. Okay, we're going to start at write small, negative infinity, and we're going to go to 1, close it, but it's not included. Union, take the gap, pick up where we left off at 4, and then we're going to go to infinity. I would suggest you try the next one on your own. Pause the video right here and do it. For this next one, notice I have negative infinity here, and I'm going to stop at -3. I'm going to have a union. I'm going to pick up at -1, and I'm going to go to positive infinity. You might want to write this one first. It really doesn't matter, whatever order you're more comfortable in writing them. You could write any of them first. So this is going to be negative infinity to -3, included and union, pick up at the -1, which is also included, and go to infinity. How would I write this in inequality notation? I have symbols, those help us. So I have x and I have a -3, or I have x and then I have a -1. For the -3, I'm going to use the less than or equal to symbol. For the -1, I'm going to use the greater than or equal to symbol. All right, so that's the review on that. There's one more thing I need to review kind of quickly here at the bottom, because we're going to start solving inequalities, and so you need to remember, and I know for sure you've learned this, but it's been a long time, you've slept a lot since then. When you divide or multiply by a negative number, remember we have to flip our inequality symbol. What do I mean by this? We solve inequalities just like we solve equations. We just have to be mindful that it's not an equal sign. If you're doing these problems and you put an equal sign, I have to mark it incorrect. There's no equal sign, it's an inequality. What we're saying is that we don't have one definite solution, we have ranges of solutions. All right, so here, look at this first one. If this was an equal sign, I know that there's 2 multiplied by x. I would divide by 2 to get x by itself. We're going to do that here too, because we're going to pretend like it's an equal sign, but it's not. So here we have x. We're going to keep the symbol because we didn't divide or multiply by a negative, and we're going to divide 6 by 2, which is 3. The next one is very similar. I have something multiplying by x. I'm going to divide, but this time I'm dividing by a -2. Anytime that I divide by a negative, I change the sign. So this cancels, I'm left with x. Flip your symbol, and 6 divided by -2 is -3. For this next one, we would add or subtract first, just like in an equation. So we're going to do that in an inequality, but we're going to be mindful of our symbol. We subtracted, our sign does not change. Our sign does not change when you subtract. It changes when you multiply or divide by a negative. So here now I have to divide by a -3 on both sides, and when I do that, I'm going to be left with x. Flip your sign, -2. 2 more. Subtract 6. You have -2x is greater than 4. Notice my sign didn't change because it was just subtraction. Divide by -2. Oh, we're dividing by a negative. Our sign has to flip, -2. Look at this last one. Y'all decide what you move first. I always move the smaller x. We're subtracting x, so we're not flipping sign. This is -5 is greater than 2x plus 11. Subtract 11. You're left with -16 is greater than 2x. Divide by 2. Even though we are dividing a negative, we are not dividing by a negative. Your sign stays the same. So it's going to be -8 is greater than x. We are not dividing by a negative. Our sign doesn't change. You can divide negatives and not change your sign. You can't divide by a negative and not change your sign. But x should always go first, so I really like this problem for that reason. Do you see here that x is last? No, I need x to go first, so I'm going to rewrite this. X is going to go first. Notice that the arrow should be pointing towards the x. We're just going to write it differently, and -8 goes on the other side. So this would be my final answer. All right, you have a practice. This is due next class. Please notice this is not an Edpuzzle video. It's a regular video because it's up to you if you want to watch this. If you don't watch this, you're going to be lost next class. So I'm going to know. You will have a DOL over this. So make sure you copy all these notes and you do your practice by next class. Miss Lee or Mr. Jennings should have already picked up your practice 5. If not, it is late. They have been instructed not to take it if it's late. If it's late, you need to bring it by my room on Tuesday. All right. Get to work. Good luck. See you guys soon.